Now, why XML and what is use of XML? Because whatever frameworks we are going to talk about, or we are going to see, or whether it is SAP, or whether it is ABAP, or whether it is mainframes, XML has played very important role. Now, what is role of XML and how actually we are going to start up with XML? Right now, our approach will be to understand practically what XML is, and then we will go and we will talk about utility of XML. See, XML stands for Extensible Markup Language. Now, why does it came? Why actually XML came? What was the reason of XML coming into computing world? In late 90s, when you say data transfer between two different systems started, each and every system was made up of different you say circuits. On that, different operating systems were there, different languages were there, and both systems wanted to communicate with each other. For example, when you want to do some online transaction, you want to buy something, your portal, shopping portal has to talk with bank because money need to be transferred or monetary transaction need to happen. Now that banking software might be written using different language, and your online shopping might be written using different language internally. So how they will communicate with each other? If I want to communicate with someone who knows Chinese and I'm not aware of Chinese, he is not aware about my language, we need to adopt a common mode of communication, right? And that common mode of communication in computing world is XML, where all platforms will understand XML in common way. So XML was adopted as a standard in order to create communication between two different systems, in order to adopt something where meaning of data transfer is common. So whenever I want to send something to X system where different language is being used, I will ensure that I am sending information in form of XML. Similarly, when he has to send some information to me, he has to convert information from his system language to XML. So XML is a language which was adopted in order to get a common portable language of sharing information. Okay. Now, why actually they adopted it in form of markup language? For example, first of all, we need to understand what is markup language. Now, this markup language is something which is used in order to tag your plain text. For example, if I assume that I want to write some data. So, in order to write some data, I'll be using what? So, I'll just write here something so that you can understand. For example, if I want to write some information, some data, and I'm writing this. If you see here, I'm writing here something. Here I'm writing, you say 3000. Now, are you able to understand what is meaning of this 3000? No, right? So this is what is data. Data that I have written here is 3000, but this is not having any meaning. Now, if I write here same thing using a tag, I'll write here quantity, and here I write 300 or 3000, whatever. You will be able to understand that this 3000 is something related to quantity. So this is what is called as tag. This tag has added meaning to this data, and that is what is objective of markup language. So in order to specify what is markup language, we can say that when data is tagged with its meaning, we call it as markup, right? Is it clear? Because I need prompt from you. This is what is markup. This is what is called as tag. This is what is data. This data is magnitude, and this is what is information about this data, right? This is what is meaning of markup language. Now, why do we call it as an extensible markup language? We call it as an extensible markup language because concept of markup language came actually from something called as HTML. There was a language called as HTML. Now this is what is mother of all markups languages which exist today. In other words, concept of markup was derived from HTML. This HTML stands for Simple Generalized Markup Language. Now from this HTML there are other markup languages like HTML, which is used for presentation, content presentation of content on browser. This is what is objective of HTML. Now HTML is derived from HTML, but if you see here, this is presentation of content. For example, if I want to present that 3000 in form of, you say, a bullet, I can take here UL, that is, and here I can take LI. So this adds presentation meaning. It is not telling anything about what data is. It is just telling how data need to be presented on browser. So this is what is one of the special languages which was derived from HTML. In order to help us in adding meaning to data, a language was derived called as XML. This is for adding meaning to data. In other words, this qualifies your data, it tells about data. So HTML is meant for presentation of content and XML is meant for representation of content. That content represents what? HTML is fixed, like HTML is meant for browser, but XML is not fixed. XML is meant for any system that wants to represent content, that want to add meaning to content for other systems. So whenever we talk about diversified systems talking to each other, we can go and we can use XML as a language. Okay. So is it clear what is ML? That is markup language. Markup language is a way of tagging data to provide information to someone. Like HTML, we are tagging data here to provide information to the browser that how he has to display content. Similarly, we can use XML in order to represent data for the system to whom we are supplying that data. This is what is objective of XML. Now what does this X means? X means extensible, right? X means extensible. So when I say X means extensible, meaning is very simple. Meaning is, see, in different domains, data that will flow between different systems will be of different type. For example, in banking, you will have account information. In case of shopping cart, you will have order information. In case of supply chain, you will have different information. In case of HR, you will have profile information. In case of hospital, you will have patient information. So you see, you don't have any fixed tag, you don't have any fixed markup. Like in case of HTML, it is fixed because it is meant for browsers. But in case of XML, it is not fixed. This is the reason why we say that XML is an extensible markup language. You can create your own tags depending on the domain, depending on the data, depending on the form in which you want to represent that data. That is what is meaning of extensible, right? So you can say this as well, that I can use XML to create my own markup language which is meaningful for my domain and my partners. It's clear? So if I'll ask you to differentiate between XML and HTML, you'll be able to differentiate, right? Why? Because HTML is meant for presentation, XML is meant for representation. Okay, it tells about data. Present HTML tells browser how to present that data. This is what is most important and basic difference between XML and HTML. Second important difference is, in case of HTML, tags are predefined, but in case of XML, tags are not predefined. Why tags are not predefined in case of XML? Because different domains will have different ways of representing the same data. Even two banks, they may treat two accounts in different way. This is the reason why we can say that XML is not having predefined tags. Tags are defined depending on the usage, depending on the domain. Is it clear? It's clear, right?
Yes, it's clear.
Fine.
Hear me, Niranjan?
Yeah, I can hear you. Hello? I think someone is not on mute. Deepak, are you there? Or Peter, are you there? Because I can see Zerentech host. Okay, thanks. Right? Fine. Now let's move. Who gave this XML? From where this XML came? And why everyone adopted XML as a single language, as a common language? Now please remember that XML is maintained by a governing body, and that governing body is W3C. Right? So you can say XML standards are maintained by W3C. This is the reason why everyone will treat XML as a common language, as a similar language, you can say. So since W3C maintains standard, everyone will have common interpretation of the data. So this makes XML as a standard markup because W3C maintains it. Right? W3 means www, World Wide Web. Right? So this is what is another reason of XML being adopted universally by different systems, by different companies. Okay. Now let's come and start talking about how actually we can create an XML. First of all, you need to have domain understanding. First of all, you need to define that what I need to send to other systems, and then you need to structure your data, which we are going to do now, right? In order to create XML, you can use any editor, whatever editor you want, you can use those editors. If you are from Java background, we are going to use only one editor throughout this training, whether it is SOA, Cloud, or you say Advanced Java, or Java Web, Java Frameworks. We are going to use one IDE throughout, and that IDE is what is used in industry also. That name of that IDE is Eclipse, right? So I will launch here Eclipse, and now after launching Eclipse, I'll show you how to write your first XML. Okay. So I'll just go here to my applications and I will launch Eclipse. Now, if you have not installed Eclipse, you have to install Eclipse, and it's very simple. You have to first install Java, JDK 1.7, and then you have to just download Eclipse for JEE developers, and you have to extract it. You have to double click on the Eclipse. Eclipse will get launched. If you have not installed, I will be there with you while installation. Right, so I'm launching my Eclipse. What is basic objective? I'm going to treat this Eclipse. I'm going to make this Eclipse as my IDE. Right, so now I will create a new. Whenever you will launch Eclipse, it will ask you select a workspace. Now, what is this workspace? Workspace, you can say, is the directory where all your work will be stored. As of now, you just remember this. I'll click on OK. Shruti, can you mute yourself? Shruti, can you mute yourself? You are not on mute.
Yeah.
And say it also. Yeah. Now you see I have launched Eclipse, and Eclipse is getting launched. It is asking some warnings you will not get because you have not added any plugin. Now this is what is your work area of Eclipse, where you will be working. As I told you, whatever we will do in Eclipse itself. Now first step is, after creating workspace, create a project where we will keep all our XML related files. And in this, see, new, I'm going and I'm selecting static web project. Okay. So you can write XML in any type of project, as I told you, because it is platform independent, it is language independent. I have selected the static web project because first half we will work, you can say in phase 1 we will be using web as our primary target. So I'll just write here first, this is our first project, just write first, click on next. Now choose context root, click on finish. As I told you that you can write XML using any editor, there is no problem, but I am using it because we are going to work with this ID. Now you have your project ready. Inside this project you will be creating your project files. What file we are going to create? We are going to create XML. See, I will go to web content, right click, new, and you see I am going to others, and in others I will have something called as XML. You see here we have XML. In XML I am selecting XML file. Click on next. Let me name this XML file, for example, customers, or better is to take something which we all are aware, employee. When I say employee.xml, it means this file will carry information about employee. Just click on next, click on finish. So now once you do this, you will get design and source. I will go directly to source, and if you see here, your ID has added one line, right? So here itself, now I will explain you what is structure of an XML document. It's very simple. First line that you can see here is called as, now this is what is comment I'm adding, it's called as processing instruction. This is what is processing instruction. Now what do we mean by processing instruction? See, your XML will be read by applications, right? Now if you want to tell your application who is reading XML, and that application which reads XML is called as parser, okay, who is reading XML, you want to tell that, see, please treat this XML document as a document of version 1.0 and use encoding UTF-8 in order to interpret it. So this particular information is meant for parser. This is the reason why we call it as processing instruction. This is not data. It's not telling you about employee, right? It is something which you are asking your parser to treat this document as, right? This is what is called as processing instruction. Second part is grammar. Let me go and write here grammar. Now grammar is something which tells structure, what should be the structure of XML. Structure of XML, right? It's not mandatory, it's optional, but we are going to discuss about grammar in detail, right? Then third thing is style sheet. Okay, fine, you have represented data. Now I want to present this data in form of HTML. So what should be displayed in what style? Employee ID should be displayed in red color, employee name should be displayed in green color. So you have to specify style sheet, right? Style sheet is how info will be presented. Now this is also something which is not mandatory, right? So any complex XML document will have these important parts. Now after all this, you will have most important thing, that is data, right? So this is what is typical structure of an XML document. So if someone is asking you what all are important parts of XML document, very simple, processing instruction. Then we can have grammar that tells or controls structure of XML. Then we can have style sheet that tells how information will be presented, and then we will have data, right, which tells detail about information, right? Fine, you forget about this grammar as of now, forget about style sheet. Now how data need to be written? See, I am writing here employee. or EMPS, right? EMPS opening, EMPS closing. Inside this, I'll have EMP, right? And here I'll have ename. And let me write here Amit. And here I'll have salary. Let me write some salary here, right? So if you see now, you have represented EMPS, which as of now contains how many EMP? One EMP. What is name of the EMP and what is salary of the EMP, right? So this is how you will be creating an XML document, right? It's clear, simple, right? Now, when you create this, you have to follow some rules. Okay, so I'm going to write now rules that you have to follow when you are writing your XML document. Okay, so here I will write all rules. First rule, case sensitive. Your XML is case sensitive. So when I say case sensitive, it means if I have EMPS opening as capital, I should have as small, I should have the same case. Otherwise, problem will be there. If I save it, you will see here it shows error. Right? It is saying that you have to end the tag EMPS with the matching tag. That's what it will do. So this proves that you have XML which is case sensitive, right? Now, second important rule. If I say second important rule is one root. Each XML document must have only one root. So if I will go and add another root here, for example, say I am writing customers. Now this XML document seems to have two roots, right? One is EMPS and second is customers. So you see it shows you what? Error. The markup in the document following root element must be well formed. So this helps us to conclude that we can have only one root, that is rule in case of XML. Right? Third important rule. Properly nested. Now when I say properly nested, it means if I have started ename here, I should close that ename at the right place. Right? I should close this ename at right place. For example, I am closing ename after EMP. You see it's error. Right? So this is what is one more important rule that you have to follow. I'll just go here and we'll see properly nested. So nesting must be proper. Fourth, all opening tags must have closing. Right? So if I have opened a tag called ename, I should have closing tag. Right? So this is what is another rule that you have to follow. All opening tag must have closing tag. Okay. Then comes fifth rule. Attributes must be attribute value, let me write. Attribute values must be quoted. You can use single quotes or even double quotes. Now what is this attribute value? See, there are two ways in which you can specify information. One is in form of element. So this is element. Ename is the element. Second one is in form of attribute. For example, here I am writing EMP ID equal to 1, A1. Now if you see, this is what? This is attribute. Now a big question that I get, or we ask to ourselves always is whether I should go for an attribute or I should go for an element, because if you see same EMP ID, I can specify in this way also. You see, I can specify this EMP ID even in this way. So why I should go with that, right? So you have to decide now whether I should go and make EMP ID as an attribute of EMP or I should make it as a child element of EMP, right? There is no hard and fast rule, but there are some guidelines which we can follow. Okay, so we'll see what guideline we can follow. Guideline for using attribute is very simple: search centric. Better is to go with attributes. And if you feel that modification centric, data may undergo modification frequently, you can go with element. So if you see, EMP ID will not frequently change, and most of the search will use EMP ID. So this helps us to decide that EMP ID will be an attribute. An attribute is always in pair equal to name of the attribute and value, and if you see, value must be quoted. If you will not quote this value, you will get an error. It tells you clearly that open quote is expected. So you can go with single quote or you can go with double quotes also. It's up to you. So these are 5-6 rules that you have to keep in mind whenever you create an XML document.
Niranjan, this is Amit here.
Yeah, Amit, tell me.
When you say search centric, I mean, what does it really mean? What search are we talking about here?
See, whenever we talk about data, assuming that data is stored somewhere. For example, here your data is stored in a XML file. Now, what all operations you will do on data? Basically, you will do following operations on data. If you see, it can be classified as CRUID, which stands for create, read, update, insert, and delete. This is what we do on data, right? Fine. So when I say update, for example, salary can be updated. When I say insert, a new employee can be inserted. When I say delete, an existing employee can be deleted from this particular repository. When I say read, it means I want to read data from this. Now read will be based on what? There will be some queries, right? For example, get me employee whose ID is this. So if you see, employee ID is something which is relevant only when we search, when we want to search. Otherwise, there is no need of employee ID, right? Each and every employee is given a unique employee ID so that he can be uniquely identified, and that will not frequently change. So first thing is, EMP ID will not frequently change and search will depend on EMP ID. Now for example, your search is dependent on department. I want to get all employees who are from accounts department. So department becomes an attribute of employee, right? So I can go and I can write here department, whatever department he is in. So I took department also as an attribute. Why? Because in my scenario, in my business case, I am searching employees on basis of department, right? And this is just guideline which you can follow.
Oh, so this is not a real search. This is just a representation of the data here.
Yes, and it depends. These are guidelines which are there. That search centric, better is to go with attribute, and something is modification centric, better is to go with element, because modifying an element is easier.
Okay,
you will get ename and then you will update ename. Right, so this is how you will be creating an XML document. Is it clear? So I'm just going here. I will launch it with Firefox. Let me go and launch this file. and you see here in browser it comes in tree view. Now I'll go and I'll add more employees to it. Just copy and paste this, change name, save it, go to browser, refresh it. Now if you see here, now it means browser is able to understand XML, so only he is able to create this tree view and he is able to tell who is child of what element, because browser contains an inbuilt XML parser. Browsers comes with an inbuilt XML parser. Okay, is it clear? So what is parser? Parser is something which reads XML document, which understands XML document. So if I want in my environment, if I want my environment to understand XML, my environment need to have what? A parser. And JDK 1.5, Java 1.5 have an inbuilt XML parser. Okay, if you don't have XML parser in your system, then you need to take an external one and you need to make that external parser part of your system, right? So this is how you will be writing your XML document. Tags are not fixed. It can vary depending on your domain. You can have a number of elements in this tag. Okay, it's clear how to create an XML document. Fine. This is what is structure of XML document. These are the rules that you have to follow when you are creating an XML document. Fine. Now let's go and discuss what is grammar, how we will write grammar. Okay. Fine. So I'll just create a file here because we have to write some notes. Now we are going to think about grammar. Now what is grammar? See, if I am sending some information, for example, assume that I am sending this information to a system, to an external system, right? Unfortunately, he is expecting this EMP ID as an element. I am sending EMP ID as an attribute. Problem, right? He is expecting salary as an attribute. I am sending salary as an element. So though he understands XML, but since I am sending data in a different structure which he is expecting, it's not similar to that structure, definitely problem will be there. So how we can fill this gap where both parties or all communicating stakeholders or partners can have common meaning to that XML? That is only possible if all of us will follow same grammar in order to interpret this data. Okay. So this is what is use of grammar. Right? Grammar provides a universal structure or rule to represent data. So if I want my stakeholders to send me XML only in a particular form, I will be sharing my grammar to them, right? Now responsibility of parser here will be to not only check whether syntax is correct or not, but he has to even go and check what? Whether grammar is fine or not. Okay, right? So in order to ensure that all communicating partners derive common meaning from that XML and they have common approach of creating, reading XML document, we have to go and we have to attach a grammar to this XML document. And in order to write grammar, you have various ways. Okay, so here how to write grammar for an XML. In order to write grammar, you can use various technologies or various other languages which are there, like DTD is there, then schema is there, then relax, ng is there. There are various options in which you can attach grammar to your XML document, right? Now DTD stands for document type definition. Means this is a way to define definition of an XML document. XML schema is from W3C, and please remember it is also from Microsoft. Microsoft provides its own schema. Okay. In Java or in most of the systems, we use W3C. If your system is Microsoft based and you are using languages and technologies only of Microsoft, you can go and use Microsoft schema also. Then relax, NG is from Apache. They also gave a tool, lightweight tool, in order to add grammar to your XML file, right? Fine. So what we are going to use? We are going to talk about DTD and schema. So here comes DTD. Now, first thing that you need to remember here is DTD itself is an XML doc. Okay, but seems to be a different one. That means it's an XML document, but the conventions which you will be using will be different because of convention that we use, right? Second, when we talk about grammar, there are two types of grammar. One is structural grammar. For example, structural grammar is more to do with content model. Okay, now what is content model? For example, here when I say EMPS can contain EMP. So what is content model of EMPS? It is EMP. Then I can say EMP contains two child elements, ename and salary, and one attribute, EMP ID. So what is content model of EMP? It is ename as child, salary as child, and EMP ID. Right? So content model is basically used in order to guide structure of an XML document. Right? So this is what is called as structural grammar. How many childs need to be there? All that comes under structural grammar. So basically, when we say structural grammar, it is control over what? Control over content model. Second, it is also control over occurrence of an element. It is also sequence, whether name should come first or salary should come first. So all this can be controlled, and all this you can control by using what? DTD. Right. So when I say I'm using structural grammar, it means I'm going and defining what should be the content model, how many times a child can occur in parent, and then what should be the sequence. Right. So this is what is structural grammar. Then again, other type of grammar here apart from structural is called as content grammar. So let me write here content grammar. Now, what do we mean by content grammar? Now, content grammar will not talk about structure, it will talk about content. For example, I am saying EMP ID must start with A. So it's what? It's rule that you want to apply on content. Okay, that's what we call it as content grammar. So content grammar controls content of an element or attribute. Right? This is what is content grammar. Now please remember, DTD can be used only for structural grammar. DTD does not support content grammar. Okay? DTD does not support content grammar. Now, why actually this DTD is not supporting content grammar? Because DTD is not aware about data type. See, I can apply constraint only if I am aware about data type. For example, salary. Salary should not be more than 20,000 or less than 10,000. So here, I cannot apply this constraint using DTD because for DTD, whatever data you will enter, it will always be string. right? So it makes DTD incapable of writing content grammar, right? So please remember, this is what is constraint or disadvantage of DTD, right? Is it clear? So you can say that DTD is a type of tool or a language that we use in order to define our XML. Okay, there are two types of grammar. One is structural, second is content. Structural grammar is more focused towards content model, occurrence and sequence, and content grammar is more focused towards controlling the content of the element. DTD cannot be used for content grammar because he is not aware about data types. Then how to write content grammar? You have one solution, that is schema. So you can say schema can be used for structural as well as content grammar, right? So it's clear. Shall we start talking about how to write DTD now? Is it clear?
Yes.
Okay. Hi.
So Niranjan, one question here.
Yeah.
When a parser passes a XML file, is it mandatory to give it a DTD file also, or is it that it can just pass the XML file?
Okay.
Or
It's not mandatory, because if I say what is parser, first of all, parser is a small tiny software that reads XML and tells you whether XML is well formed. When I say well formed, it means no syntax mistakes, is well formed. And then second task that it checks for is valid. Now when I say is valid, it means here I am talking about grammar, right? Now there are two types of parsers. First parser is non-validating parser. Now this non-validating parser will not check grammar. If you want grammar check, you have to go and you have to use what? Validating parser. Will check validity, right? Most of the parsers which are there, they are non-validating parsers, right? You have to go and switch on or change from non-validating to validating parser. So it's not mandatory that XML document must have DTD, or if it has DTD, it must be used for validation. It's up to you. For example, browser contains non-validating parser. So even if your grammar is incorrect, still browser will display the content. Okay. Amit, is it fine?
Yeah. So just one last question on this. So the parser which you were mentioning, which came with 1.5, right? That has validating parser also, or is it just a non-validating parser?
See, any validating parser can be treated as non-validating also, because in validating parser you will have a property called as validate. If you set it to true, it becomes validating parser. If you set it to false, it becomes non-validating parser.
So when you make it a validating parser, you have to also supply it a DTD, right? Or is it that
Yes,
how will it know
you have to supply a DTD, otherwise it will give you an error. You can say
Okay.
there are three levels actually. One is error, second is warning, and third is fatal error. This is what you say parsers will give, right? Fatal if syntax problems are there. Warning if those things are there which can be ignored, like white spaces and all. Error, if you are asking your parser to validate and DTD is not there, right? So it generates error.
Okay.
Fine. Now what we will do, we will start writing our first grammar. Okay. And as I told you, grammar contains what? Structural grammar as of now. And here we'll have content model, occurrence and sequence. And this is what we want to control. So let's talk about content model. See, when it comes to content model, you can have following content models for your element. Elements with element. Second, elements with data. Third, elements with neither child nor data, called as empty. Fourth, elements with anything. You can have anything in that. So you can say no constraints. You can leave it empty. You can have child elements in that. You can have data as well. So this is what is content model. Okay, element with element, element with data, element with neither data nor child, element with anything, no constraint. Right. This is what is possible content model of an element. So let's go and see our employee. EMPS is there, right? So what is content model of EMPS? EMPS can contain what? EMP. So let me write here. EMPS content model is here. Content model is EMP. Now let me take EMP. As we can see, content model is ename and salary. What is content model of ename? It is data, right? And what is content model of salary? It is data. So this is what is content model that we have in our current XML document. Right? Let me remove attribute for now. Right? This is what is content model. Now how to write the same content model using DTD as language? Now for this I will request you to remember few things. Okay? We declare content model of element, declaring content model of an element. In order to declare that, I have to use exclamatory mark, element, give a space, followed by the parent element, give a space, followed by its content model, EMP. So this is what is DTD language. Same thing we will do for rest of them also, right? I'll go and I'll create a DTD. You understood, right, how to declare an element? This is how we will be declaring an element. Okay. So how many elements are there that we have to declare? 1, 2, 3, 4 along with their content model. Okay. Now wherever data is there, for example, wherever data is there, I will request you to remember one more. For example, I'll take ename, give a space, and take PC data. So your parser will understand that okay, here something string is there. Okay, PC stands for parse character data. Right. So let us go and write a DTD. Go to others. Go to XML. Select DTD. Click on next. Give a name to it. Whatever name you want, I can give. Let me give here EMP. Click on next. See, this is also an XML document that I told you. Click on finish. And here I will write same content model, exclamatory mark, element, give a space, EMPS, give a space, EMP. And do this till all child elements are not, till content model of everything is not defined. EMP, give a space, e-name, salary. Now do it for element, e-name, and as I told you, here you have to specify what? PC data. Last is left, element, salary. This also is PC data. Save it. After saving, don't forget to validate it. Whether you have written your DTD itself correct or not, you should know. So see, I just validated, it is correct, no error is there. How to validate? Be here, right click, go to validate. This is how you will validate. It's clear? So DTD is ready. A simple DTD where we are discussing about only content model. Now, how to apply this DTD on this XML? In order to apply the DTD on this XML, here we have to add something, right? Because now we want to add grammar. See what I am adding. Let's go here, take dot type. See, here you have, right? Root is element. This is what is root element. Instead of public, we can take system. Why? Because my DTD is there in my system only. So why I will not go with public URL. Public is if your DTD is stored somewhere else in some other domain. Specify here name of your DTD. I'll write here EMP. I'll save it. Right. Now the minute I saved, it started reporting. What? He's saying that content model of EMPS does not match EMP. Okay. Why? That reason you will know. Bit in 2-3 minutes. See. I'll save it. Right click. Validate. That is saying that there is no problem, no error, no warning. Okay. So your DTD is getting checked, right? Now the minute I add one more EMP tag, see, I'm adding one more EMP tag. As of now, my EMPS contains only one. I'm going and I'm adding one more. I'm writing here Amit 2 and all. I'll just go and save it, and now I'll validate. When you go with validation, it tells you, see here itself it reports you, because the minute you save, it validates. Just go here. One error was discovered, right? That error you can see in problems view here, or you can also keep your this here, and you can see it does not match. Why? What is the reason why it's not matching? Very simple. By default, occurrence of EMP within EMPS is 1. This is rule. So if I want to control occurrence, we have to know some wildcards, right? So I'll write here how to control occurrence of elements, of child elements. In order to control occurrence of child element, we need to remember following wildcards. See, first one is star. Star means 0 or many. Then you have plus. Plus means 1 or many. Then you have question mark. Question mark means 0 or 1. Means you cannot have more than 1. And then you have default. For example, as of now we have not specified any wildcard. 1 and 1 means you are not specifying anything. It will be 1 and 1. See here EMPS nothing is there, right? This is the reason why it is not allowing us to have more than one child element of type EMP. I want to tell that no, EMPS can have 0 or more. So I just go and put one star here. See, the minute I put star, error is gone and your document is valid, right? Is it clear? If you have any confusion, you can ask me. So if I go and delete this from here, still it will be valid, right? Why? Because star means what? 0 or many. But the minute I change it to plus, I am changing it to plus, you will get error. Because plus says what? 1 or many, right? Now if I go and validate it, it's valid. Here's what is difference between plus and star. Is it clear? Now question mark. Question mark is 0 or 1. For example, I'll just go and change it to question mark. And you will see error. Why? Because you have more than 1. Let me go and cut 1. I'll save it. Now there is no error because question mark means 0 or 1. Right? So if I'll have only 1 or I will not have any, it will be valid. Now see, still it is valid because question mark means 0 or 1. This is how you will be controlling occurrence. Is it clear? Any questions you have, you can ask me. No questions? We'll proceed further.
They need to the default 1 and 1.
Yeah. Default when I say, yeah. Default when I say if I have not specified anything here, no wildcard. So that becomes default, and default is 1 is mandatory. You cannot have more than 1 and you cannot have less than 1. So 1 or 1, right?
Okay.
If you see, if I save it, it is correct because 1 is what is expected. But the minute I will add 1 more, it will start shouting. So this is how you will be controlling content model. I'll make it plus. Fine. Now let's go and add some more element here. Now what I am doing here is I want to add one element called as photo, and that element will not have any child element. Okay. Each employee will have photo, and I don't want any child element or any content model here. So I'll save it. Now I need to write this in grammar also, right? Let's see now EMP contains one more element called as photo, and it is of type empty because no child element, no data. So how I will specify that you see. First thing I'll go and I'll add it in content model. So I'll write here photo, and then I will specify content model of this element also. Element name is photo, and then I'll go and I'll write empty. Please remember capitals keyboard. Now I'll come here, you'll find that error is gone. Right? But the minute you add something here, start shouting. Okay? Now instead of having full opening and closing for empty elements, what you can do is you can have elements and you can close them here itself. This is shortcut for opening and closing. This is how you will be using empty elements. Fine.
Niranjan, what if you want to have empty tag or sometimes non-empty for the same one?
Okay. Come again, Amit.
What if you want to have element as empty as well as non-empty? So you need to, it can be empty or non-empty. So is there a way we can provide that?
I told you, right? That is what is called as any. For example, I'll take description. Okay. Assume that I'm taking one more child element here called description, and I'm giving you freedom. Whatever you want. You want something. If you want this to be empty, you keep empty. If you want some data, you can keep data. Whatever. So I'll just go here and add it. Let me add here after photo. I'm adding description. Okay. And I want, as you told, that it can be empty, it can be non-empty. I'll just go here, take element. I'll take name of the element, description, and I'll take any. Keyword is any. Now you see there is no error. You write something, still there is no error. You don't write, you make it empty, there is no error.
Okay.
So this is how you will be using description. So I feel that now you will be able to at least maintain a structure, and that too occurrence. Along with occurrence, content model. So first thing that you will do here is when you are planning your data, when you are planning structure of your data, you need to relate it with XML, and then you need to decide that how actually you will be handling that, right? So once till here it is clear, time has come when we can go and we can add attributes also. Shall we go ahead and add attributes? Because as of now we have not added any attribute, right? We have not written grammar for any attribute. Now let's go and add. Now please remember, we can add certain constraints on the structure, and those constraints can only be applied at attribute level. For example, I want to do what you say. I want each EMP must have an attribute EMP ID, and content of EMP ID must be unique, no duplicates, right? This is a constraint. EMP must have an attribute EMP ID, and content of EMP ID must be unique. So if you know database, you can call it as primary key, right? Something similar to primary key. You can see you will be able to apply entity integrity constraint, where each and every element or each and every child is unique, right? So shall we go and decide how to apply it? Right. Now you see how. You have to define now attributes. So you will take something called as @list. Now @list means attribute list. Within a single one also you can specify, but best practice is to have it specified differently. Now EMP ID is attribute of what? EMP, right? So this is what is name of the element, name of the attribute, followed by value type, which is ID, followed by default type. I am saying here hash required. Now I feel that the minute I say hash required, you will understand, right? Hash required means what? Mandatory. ID is EMP ID is mandatory, right? So let's go and add it. I'll just go and add this line. It's enough. I'll go to my DTD and I'll add it here. I'll save it. Now you see you'll get errors. What error? This error. EMP ID is required. Now I'll go and I'll add EMP ID to it. Let me go and add E001. I'll save it. Error is gone. Now I'll add one more employee and I'll try to keep EMP-ID duplicate. I'll save it. It clearly tells you that see, attribute of type E must be unique within the document. I'll go and I'll change it to, and this is how we are able to maintain uniqueness of element within the tree. Questions? Ask me. Is it clear?
Is that ID keyword compulsory?
Yes. If you will not use ID, then it will not be unique.
Okay.
Okay.
So like ID, there are many other keywords, or is it that this is the only one?
There are many others.
Okay.
Right.
So
now,
this ID is
yeah?
this ID specifically used only to refer to any IDs, right?
Yes. If you want uniqueness, you will specify ID.
Okay.
Now, sometimes what happens, we don't want employee ID to be mandatory, but whenever it is being used, it should be unique. For that, you see what we will do. We'll just make one change here. Instead of hash required, we'll make it hash implied. Implied means optional. You are not using employee ID, fine, but if you are using, it should be unique. For example, now if I will delete this EMP ID from here, it's working, right? Because implied means optional. And if you are specifying, you specify that unique value should be used. This is what is difference between implied and required. Right? Now, I don't want to follow uniqueness. For example, assume that now what I am doing is I am giving one more attribute here called summary. Okay, and in summary I want them to write whatever they want. I don't want to control that value should be unique and all. Right? And I want to make it mandatory. Write something, it's mandatory, but write whatever you want. I'm not going to check for uniqueness and all. See how we'll do it. Same thing, I'll just go and take up an at list. Please ask me in case if you are confused anywhere. EMP, I'm taking here summary, followed by special one which is going to come C data, followed by you want to make it mandatory. What we need to take? Required. But you are free to write whatever you want. There will be no check of uniqueness. I can write whatever I want. Right. So there is no control now. Your data here can be anything. This is how you will be using C data. C data is character data, which is not parsed by your XML parser. XML parser will ignore it. It will give you whatever you have written there. Is it clear? Clear, right? You all are there? Okay, fine. Now, sometimes your need is in your company you have 3 departments. You say D1, D2, D3. Okay, you want that this department value should be either D1, D2 or D3. Nothing else apart from that, right? It means value to this department should be from a predefined list. So let's see how to do that in DTD. It's an attribute, so I'll take at list followed by ENP followed by department, and here we have to maintain a list, which I'm going to do. D1, give a 5 symbol. D2, give a 5 symbol. D3. Now, if someone is not specifying department, you want him to be part of D1 itself, you can do this. See, as of now, in this XML, we have not specified department, right? And here, I am giving D1, it is part of the list, it's valid. But if I'll give something which is not part of the list, like D5, it's invalid. Right, so this is how you are able to control. And I have said that if I am not specifying department, treat him as a person who is there in department 1. Department 1 becomes default one, right? Now you see what I am doing. I am going to my browser. I am trying to browse it. It's the same one. It's, if you see, by default when your parser will read it, it will read D1. Just go here and open it with this. Right. So this is not reading, but your parser will understand. Whoever is reading. Once I will show you with Java how to read, then you will come to know. Right. This is what and how you will maintain a list. Is it clear? See, you can apply certain level of control there, right? Now let's go and talk about some other constraint also. See, here someone has written special characters equal to. I don't want. I want them to use valid terminologies, right? So see what I'm doing here. I'm going to this, and instead of C data, I'm saying now my XML parser will parse whether you are writing meaningful data or not, NM tokens. And the minute I'll go and save it, I'll get an error. Why? Because you are using some invalid characters. Now if I save it, it's okay. This is what is difference between NM tokens and C data. C data you can use if you want your parser to ignore. But if you want your parser to check for at least no special character should be used, you can go with NM tokens. So NM tokens are valid XML tokens, which parser will parse. It's clear. This is how you will be writing DTD. See, I can finish schema also in another 1 hour, but I don't want to do that. Now I want you to work with an exercise, and that exercise is write DTD which applies following rules on XML. First, customers can have one or many customers. Second, each customer must have unique customer ID. Third, customer type attribute must have value of only type, that is normal customer and privileged customers, right? So this is what I wanted to do. Apart from this, customer will have custom name, right? Phone number as child element. Is this fine? Will you be able to do it?